The universe is 13.8 billion years old. In that time, 1 trillion stars have burned and collapsed. Galaxies have formed, merged, torn apart, and formed again. The conditions for life, liquid water, stable orbits, organic chemistry, have existed in some corner of this universe for longer than the Earth has been a rock. And yet, you have never received a message from somewhere else. No probe has entered our solar system from outside it. No signal has resolved itself from the noise of deep space into something intentional, structured, unmistakably alive. No visitor, no artifact, no echo of a civilization that burned bright 1 billion years before we learned to write. We have been listening since 1960. 65 years of radio telescopes aimed at the dark, waiting for something to answer. Nothing has. That silence has a name. It's called the Fermi Paradox, and the longer you sit with it, the more unsettling it becomes. Not because the silence is strange, but because the simplest explanation for it might be the one none of us want to say out loud. In the summer of 1950, 4 physicists were walking to lunch at Los Alamos National Laboratory. They had just been laughing about a cartoon, a New Yorker drawing of aliens stealing New York City's trash cans. The conversation drifted, as it does between physicists, into the improbable. One of them asked, "If the galaxy is teeming with civilizations, where is everybody?" His name was Enrico Fermi. He had already won a Nobel Prize, helped build the first nuclear reactor, and developed equations that still underpin modern physics. He was not a man given to casual questions. The question wasn't casual. Here's the shape of the paradox he named. The Milky Way contains somewhere between 200 billion and 400 billion stars. Roughly 20% of them, conservative estimate, have planets orbiting in the habitable zone. That is tens of billions of potentially life-permitting worlds in just this one galaxy, which is itself one of an estimated 2 trillion galaxies in the observable universe. The galaxy is also old, older than the Earth by billions of years, which means that if life arose elsewhere even once, if even a single civilization achieved what we have achieved and kept going, they have had millions, potentially hundreds of millions of years, more time than we have had to expand, explore, and leave evidence of their existence. At even modest sublight speeds, a civilization could colonize the entire Milky Way in under 50 million years. Which sounds enormous until you remember that 50 million years ago, your ancestors were small rodents hiding from dinosaurs that had already gone extinct. The math says the galaxy should be full, the sky says otherwise. That is the paradox. The numbers demand a crowded universe. The evidence gives us silence. Both cannot be true, which means something, somewhere in our reasoning, is catastrophically wrong. The question is, where? The optimists have answers. They always do. Maybe they're too far away. Radio signals degrade across interstellar distances. Even a civilization broadcasting at full power for 1 million years might produce a signal indistinguishable from background noise by the time it reaches us. We have been listening for 65 years. In cosmic terms, we have been listening for less than a single breath. Maybe we're not listening right. We assume radio waves because that is what we use. But a civilization millions of years ahead of us might have moved through radio the way we moved through smoke signals, briefly then passed it entirely. We might be listening on the wrong frequency, in the wrong direction, for the wrong kind of signal, because we cannot yet imagine what the right kind would be. Maybe they're here and we don't recognize it. Some researchers argue that advanced civilizations might communicate through methods so far beyond our comprehension that we would perceive their signals the way a bird perceives the internet, as something in the environment that simply doesn't register as meaningful. These explanations are comforting. They preserve the populated universe. They let us believe the silence is a detection problem, not a population problem. But they all carry the same quiet flaw. They require every civilization to be silent in every detectable way simultaneously. Not just communications, artifacts, probes, Dyson structures around stars, large-scale engineering visible across light years. One civilization with the ambition and the time should leave marks we could see from here. We see none. The optimistic explanations require a conspiracy of invisibility across every technological stage of every civilization that may have ever existed. That is a lot to ask of a coincidence. In 2008, a Chinese author named Liu Cixin published a novel called The Dark Forest. It proposed a solution to the Fermi Paradox that is not comforting at all. The premise is this: every civilization needs resources. Resources are finite. Civilizations, by their nature, expand. And you can never fully verify the intentions of a civilization you cannot see, cannot understand, and cannot predict. Trust across that kind of distance and difference is not possible to establish, so the rational move for any civilization advanced enough to detect others is not to make contact. It is to eliminate the competition before the competition becomes a threat. The universe in this model is a dark forest. Every civilization is a hunter, moving in silence, because any sound reveals your position. And in the dark forest, revealed positions get you killed. The silence, then, is not emptiness. It is strategy. This is not merely science fiction speculation. Elements of the dark forest logic appear in formal game theory. In A Prisoner's Dilemma, scaled to civilizational survival across interstellar distances, where defection is costless for the attacker and fatal for the detected, the Nash equilibrium is silence. It is the only stable strategy. If the dark forest is correct, then SETI, our 6-decade search for signals from other civilizations, is not a program for making contact. It is a program for announcing our location to entities we do not understand and cannot negotiate with. In 2015, Stephen Hawking co-signed an open letter warning against active METI, messaging extraterrestrial intelligence. Hawking had said publicly that contact with an advanced alien civilization would likely go the way first contact usually goes, when one civilization is dramatically more advanced than the other. History gives us no optimistic examples of that scenario. The dark forest is not a certainty. It is a logical structure that fits the silence without requiring coincidence or invisibility. That alone makes it worth sitting with. Because if it's even partially right, we have a problem. We have already sent signals. The Voyager probes, launched in 1977, carry golden records engraved with our location, our biology, our mathematics, our music. They are traveling outward right now. We have broadcast television and radio for nearly a century. A sphere of electromagnetic noise 200 light-years in diameter is already expanding from this planet, announcing that something here is alive and technically capable. We spoke before we understood what speaking might mean. But there is a third possibility, and it is the one that should keep you up at night. In 1998, economist Robin Hanson published an essay called The Great Filter. It asked a different version of Fermi's question. Not where are they, but what stopped them? The logic begins here. The path from dead matter to a galaxy-colonizing civilization is long. It includes dozens of steps. The formation of a star with a stable, habitable zone. A planet at the right distance. The emergence of self-replicating molecules from chemistry. Single-celled life, complex, multi-celled life. Sexual reproduction, which accelerated genetic variation. Animal cognition, tool use, language, industry, science, spaceflight. At every step, something could fail. Most things do fail. The universe has run this experiment on billions of worlds, and the evidence suggests that somewhere along that path, there is a step so unlikely, so catastrophically difficult to pass through, that almost nothing makes it. That step is the Great Filter. Here is where it gets personal. The Great Filter is either behind us, or it is ahead of us. If it is behind us, if the rare, nearly impossible step was something that already happened in our history, the emergence of life from chemistry, or the leap from single-celled to multi-celled organisms, or the development of language, then we are the miracle. We are the thing that almost never happens, and the silence makes sense because we are alone or nearly alone, in a universe that almost always fails before reaching us. That would mean we matter in a way that is almost impossible to overstate. But if the great filter is behind us, we should expect to find the universe littered with dead stars, worlds that got to some early stage and stopped, microbial fossils on Mars, organic chemistry in the clouds of Europa, evidence of life that began and did not continue. The more early-stage life we find elsewhere, the worse the news, because it means the filter is not the beginning. It means life starts easily, and something else stops it. Which brings us to the second possibility. If the great filter is ahead of us, if the catastrophically unlikely step is still in our future, then the silence is not evidence of our uniqueness. It is evidence of what happens next. It is the graveyard we have not yet learned to read. What could the filter be? The candidates are not abstract. They are familiar. Nuclear war, climate collapse, a pandemic engineered by biotechnology that has outpaced wisdom, an artificial intelligence that optimizes for goals misaligned with human survival, resource wars over a finite planet with infinite appetites, civilizational complexity so high that it becomes brittle, prone to cascades that collapse it entirely. These are not speculative. They are processes already underway at various scales. The question the great filter asks is not whether these things are possible. It is whether any civilization in the history of the universe has successfully navigated all of them. The absence of detectable civilizations in the sky suggests the answer may be no. Every civilization that has ever reached radio technology in this galaxy may have been looking at the same sky and hearing the same silence and drawing the same conclusions, and then failing to survive the conclusions long enough to matter. Sit with that for a moment. The silence is not emptiness, it is a pattern, and patterns have causes. Here's what the Fermi Paradox actually is, beneath the astronomy and the game theory and the probability estimates. It is a mirror. The question it is asking, really asking, is not about aliens. It is about us, about what we are, about how long things like us tend to last, about whether intelligence, once it arrives in the universe, is a beginning or a brief flicker in the dark. We are a civilization that has existed in recognizable form for roughly 10,000 years. We have had nuclear weapons for 80. We have been producing artificial intelligence capable of autonomous learning for perhaps 5. We are, by any cosmic measure, extraordinarily new. And we are already, in those 5 to 10 years, confronting questions about our own continuity that previous generations never had to ask. Not as philosophy, as policy, as engineering problems with deadlines. The Fermi Paradox does not tell us whether we will make it. It tells us that making it is the exception, not the rule. That the universe has been running civilizational experiments for billions of years and the results are not visible. That should change how we hold our choices, not with despair, with precision. If the filter is ahead of us, then every decision that increases our odds of navigating it is a decision that matters more than we know, not just for us, for the universe. Because if we make it through, if we are one of the rare things that actually persists, we may be among the first in the galaxy to have done it. That is a weight, but it is also a direction. On a clear night, you can see approximately 2,500 stars with the naked eye. Every one of them is a sun, many of them have planets. Some of those planets are older than the Earth by billions of years. If life arose on any of them, if something looked up from one of those worlds the way we look up from this one, they have had time to fill the galaxy. They haven't. The sky tonight is the same sky Fermi looked at, the same sky the first radio telescopes swept in the early 1960s, with patient certainty that something out there would answer. The same sky that has returned, decade after decade, the same result: silence. And the most unsettling thing about that silence is not that it might mean we are alone, it is that it might mean we are next. The latest in a long, quiet line of things that looked up, reached out, and then became part of the answer. You are alive at the moment when we are just barely old enough to understand the question. Whether we are also old enough to survive it, that part is still being written. The sky is dark, and it is listening.